good morning, or good afternoon, everyone, depending on where you're joining us from. We still have a few people logging in, so we're going to give them a minute to get settled, and we'll get underway. Hello again to everyone just joining us. We're just taking a minute here to let everyone get logged in. Okay, I think we're ready to go. Thank you for joining us for today's webinar. Today's webinar is being presented by Klaus Blache from the University of Tennessee. And before I introduce our speaker, I just want to go over a few housekeeping topics. Today's webinar is being recorded. We will share a link with you after the event is over, and we welcome you to revisit that content yourself and share it with your colleagues. We also invite your comments and questions. Please look at the Q&A chat box there on your screen. If you think of a question for the speaker at any point, just type it in there, and I will pose it to him or hold it for discussion at the end. As I said, today's presenter is Klaus Blache. He's the Director of Reliability and Maintainability, the RMC Center at the University of Tennessee. He's also a research professor in the College of Engineering, and before that, he served as Manufacturing Engineering Director at Cadillac. Klaus is also a past chairman of SMRP. At this point, I'm going to turn the floor over to you, Klaus, and you can start today's presentation.
Yeah, thanks. Thank you. So again, glad to be with everybody, and then, like I said, ask any questions you have. I'll do the best I can to answer those for you. What I'd like to do today is, in the time that we have, is talk and loosely transition from one topic to the other in these four areas. Talk a bit about the evolution of asset management and reliability, at a high level overview, beginning with really, reliability starting, but then quickly get into kind of what I see as observed operational challenges and opportunities from all the industries that I'm working in. Actually, this morning I'm working in a facility this week and actually doing this webinar from a plant. And then thirdly, spend some time talking about what the best companies do, and then kind of what I see coming up, transitioning to manufacturing 4.0 and really all the digital challenges and opportunities and that are going to happen with or without us, as we move forward, and some of the issues around that, and some of the things you need to get ready for that digital challenge, and what's today's climate around that, and then taking some action tied into that. So we're going to start with maybe just a quick question, kind of loosen things up. When was the word reliability first used? And I believe, Eric, you're going to handle that.
Yeah. So the poll question that Klaus posed, you can see it on the screen hopefully here, is when was the word reliability first used? And hopefully this quick poll has popped up for you, and you can select one of the responses here. We have 1816, 1927, 1948, and 1955. We'll just take about 30 seconds or so for everybody to file in their answers. All right, and we have some results here. Looks like 21% of people said 1816, 45% said 1927, 17% said 1948, and another 17% said 1955. So fairly evenly split between most of the results, except for 1927, which looks like our winner. What was the correct response there, Klaus?
It's 1816, and I actually used this question because I didn't know either. You know, I never looked up when did reliability start, or at least first get used, you know, and so on. So it was actually used in 1816 for the first time. It was actually by a poet, and it referred mainly to a person being dependable and reliable. You know that their actions were repeatable. And that was the first time it was ever used. But as we move forward in time quickly, you know, in the 20s and 30s, there was a lot of stuff going on at a smaller scale with different companies, and you know, there's going to be dozens I don't talk about, so it's not meant to be comprehensive, but just give a few samples. I know things that I have read about, know about. You know, some of this was obviously before my time too. Was, you know, Bell Labs was doing stuff in the 20s and 30s on statistical quality control and engineering design, and you know, again. At that point, you know, maintenance was still doing the fixes, and engineers were doing the design. Then it was, you know, probably going to the 40s. In the 40s, you know, a lot of stuff was done around the military, you know, tied in a different application there, and they obviously during the World Wars wanted to make sure that product worked and operated when needed. And a lot of it then was involved around electronic equipment and electronics working correctly. So a lot of the experimentation and discussion around reliability was focused around that. And again, you know, is the repeatable instruments, is the testing, is it working right, and so on. And then, you know, later on around the 60s, they started hearing words like reliability analysis and Weibull analysis, and that was Wally Weibull. You know, we actually you know, started all that, and he was publishing in committees and, you know, in different societies like IEEE, ASME, American Society of Quality Control, and I you know, I still remember seeing a you know, really small book or smaller book from Dorian Chanin on Weibull and so on. So there were people that were doing that already, even though it wasn't as widespread. And then around, I think it was around the 60s, Wally Weibull went to Columbia University, and he was doing consulting, I think first with the Air Force and then the military. And so you know, more people were starting to get involved with it. Dr. Bob Abernathy, you know, was involved in following some of this stuff, and really an early user of those kind of things. And at that time, they were also starting to get more into human reliability, because again, you can't be reliable, you know, even if you have a reliable process and a reliable product, or trying to make a reliable product, you need human reliability to make all those things work together. And then there were, you know, various committees. The IEC was the International Electrotechnical Committee. Again, remember, a lot of the stuff, as I mentioned, started out more electrical, and then you know, there was the Nolan and Heap study that everybody's more familiar with. That was the stuff, I think it started way back in the 60s and 70s, but a publication was actually later. I think it was around 1978. When that was that U.S. airline study that gave us those 6 curves that said, gee, most of the issues are really random failure, and the bathtub curve doesn't really work that well if that's how you're doing your maintenance. And that's kind of where most of the stuff still sits today. And you know, but as a result of the Nolan Heat stuff and different practices, you know, failure rates were getting better by a factor, you know, 5, 10, 15, and so on. So that's all good. You know, then John Mowbray, you know, he partnered with one of the persons from the Nolan and Heap study, and I don't remember which one at this point, but between their work and John's publishing, you know, the RCM2 book came out, which is still used by a lot of people today. We did a small guidebook when I was working for General Motors, and originally it was a lot of the stuff that we did, and a lot of other companies then got involved also, for everything from you know, Boeing, John Deere, Ford, and so on. And it was published through SAE. It was document M-110, and through the National Center of Manufacturing Sciences, because our feeling was that if we don't get the information out to the original equipment manufacturers, we can't change that much after the fact, especially for design and maintainability. So we just wanted to get a workbook out there at no charge to us, and let other people publish it and take the revenue from that. So that's how that got started. And I think that's been through a couple of revisions now, of course, with a lot of other people being involved. And then some of the stuff on like the SAEJ 1011, which defines what makes it a reliability-centered maintenance, which really describes the items in a failure modes and effectiveness analysis sheet, and then some other asset management processes around that as to what you have to do to make it a reliability-centered maintenance effort. And the word started getting used more on reliability and dependability by the different societies, and I think it's pretty close to how we use it today, which addresses more of the business needs of reliability versus just looking at some of the components and the electrical stuff as it started out. And then really from there, it really expanded to getting it whoops, going the wrong way here, to get it to the floor applications. And so, now it's being used in industry in a lot of different ways, and there's some people making a fair amount of progress. And then on the bottom is kind of the words that you see in the John Mowbray book, from starting out from the fix when it's broke to some computer usage to a lot of the stuff that we're doing today, from more analytics and the PM optimization and et cetera. But the big change now is where do we go from here? From really 5-10 years ago and 2020, 21 going forward, we're seeing this phenomenal digital transformation. And a lot of people are still looking at, how fast do I go? How fast can I afford to go? And am I ready? And it's a lot more systems thinking and a lot more data than you're used to handling. And just taking care of all the data is a big task in itself. And kind of transitioning that to opportunities and challenges that I see in different companies is I've had the opportunity to whether it's the last 50 or 200 facilities that I've been in the 10 plus years that I've been at the university, or the hundreds or more plants that I've been in my corporate benchmarking career and so on, I still see almost the same operating challenges and opportunities. People are getting pressured to do more with less, to reduce cost per unit, to decrease downtime. That hasn't changed, since forever. And then also, people are looking for more return on investment to satisfy their investors and stockholders if it's a publicly held company. That hasn't changed. And even still, after all these years, we're still working on life cycle decisions on assets. How do we get purchasing involved to spend a little bit more money up front to design in those 30 plus modules, as I call it, to get better design and maintainability? That's going to greatly reduce keeping the assets operational, and really the maintaining costs once you buy those assets. Because as we know, and you see the charts that say if you don't do the design and for maintainability, now you've already decided how you're going to spend 95% of your money over the next 10, 20, 30 years. I pulled this chart out, and because I just happened to see it as I was putting the presentation together from McKinsey. It kind of shows, because everybody's struggling with with employees and number of employees, and a lot of the experienced employees retiring, and the younger employees coming in with good skills but not the experience. And this is a chart that shows what's more important to employees and what's more important to employees. And the one that's interesting, that's really impacting a lot of places right now, is the flexible work schedule. I put a yellow dot there to see where that kind of fits. But what that means is that the employees see this as more important than the employees. And so meaning that people want more flexible work schedules. And I think this whole year and a half and with COVID has really driven that home, that over 20% of the people in the US have already switched jobs. It's slowing down just a little bit right now, but I think it's going to be closer to 40% people changing jobs over the next 2 or plus years. And that's traumatic, for people trying to do things, and everybody running shorthanded. It's a big issue everywhere. But that flexibility is what everybody wants. Other availability, loss of skills, again, it's the aging workforce. When they leave, well, things are getting more efficient, you're getting more skills, but what you're missing is that black book that the trades have that says, here's how I really run the plant. Here's the day-to-day operations that I tweak to make sure we run as effectively as possible. And that's all based on experience. And that's what the tough part is when those people leave. By 2025, 75% of your workforce will be millennials. And so it's a big transition of how do you get there and how do you train those people? And when I say not train them so much on the technical, but on the experience and the assets and the manufacturing specific stuff. When you look at what's coming up, I mean, there's roles that we haven't even heard of today. I mean obviously, you're already seeing things like augmented reality engineer. Well, that may be a common role in a manufacturing, maintenance side at some point, or technology integration engineer. Reliability, maintainability engineer. We've had that for a while, but beyond that, you may be hiring a data analytics engineer. As you go forward, if you're going to be doing algorithms and machine intelligence or machine learning and artificial intelligence, all huge items. Virtual reality engineer, algorithm engineer, human technology, machine integration engineer, autonomous transportation engineer. They're talking about flying taxis not being that many years away. Volkswagen's experimenting or has actually piloted a small flying vehicle, So things are going to be changing rapidly. Sensor integration engineer, manufacturing industry 4.0 integration engineer, not just 3, but 4D printing, additive manufacturing engineer. We do a lot of that stuff at UT. Michigan State's actually the lead for automotive, for additive manufacturing. University of Tennessee in Knoxville is the lead for aerospace. And so there's a lot of stuff done around this. What 4D printing is, because people ask that, there's a 4th dimension like temperature or pressure. That means you can do 3D printing. Let's say place something into a piece of equipment or a person getting surgery, and now based on rising temperature, that part grows to a predetermined size and shape. And so that's a phenomenal advantage now if you need to get stuff into small spaces, both for medical reasons and for manufacturing, and that's 4D printing. A lot of there's manufacturers now of spare parts for old vehicles that are doing additive manufacturing printing, and they're printing the spare parts from old vehicles rather than keeping a large warehouse. So that's starting to happen already. Cloud edge computing. I keynoted part of the OSI Soft Conference in San Francisco probably about 3 years ago now. And there was a big talk on everything going to the edge. I don't think it's going to be as much as it was touted, but there's going to be a lot more edge computing, but probably still the majority going to the cloud. And quantum computing is a whole nother ballgame. Maybe we'll talk a little about that on the last couple of slides. I still think there's an insufficient understanding and especially compliance on the key performance indicators and how they align, and understanding of what really matters. Most medium large companies have 100, some 200, or something in between there, key process indicators or metrics. But you're lucky if you can improve 2, 3, 4 items at one time and really focus on those levers that really can impact everything. So you need to understand, what are those important items and what do you work on? And so I still see a lot of places that have a lack of reliability and maintainability roadmaps linked to corporate strategies where they can really make a difference. So again, in understanding what are the levers, what are those few things you work on that can give you the greatest return on investment and take away those daily pain points. And understanding the formal process and then the hidden costs. I still see 90–95% effort on performance and very little on organizational health. That's the engagement, the people side of the business. And those that get that and spend much more time on that, they see the financial results, based on studies that I've seen. So again, are your KPIs aligned properly to line of sight from top of the organization to the plant floor? Most places have some level of business plan deployment of the goals, the high level goals of the company to metrics or KPIs on the plant floor. But are those KPIs clear enough when the people on the floor and the engineers that have to make a difference look at them? Do they really understand what can and should I do different to impact and improve those KPIs? Is it that clear? If not, you don't have the proper line of sight. With that, let's roll into another question on reactive maintenance. Eric?
Yes, we have what percentage of your maintenance hours are reactive? The options here, hopefully everyone's seeing, are less than 10, 10 to 25, 25 to 50%, and over 50%. Klaus, is there one answer here that you usually see people responding with? Not to bias our audience here, but.
Yep, I'll speak to that as soon as the answer. Yeah.
All right. It looks like our winner by a hair is 25 to 50% here.
Okay. Yeah. The question is where should you be? I published a long time ago, and I haven't seen any reasons to change it because I do continuous benchmarking and update it every 3 years. As I say, best practice should be 10% reactive maintenance, plus or minus 5%, based on your industry and how you choose to run the business, because it's always a business decision. So I say 10%. Right now in North America, from thousands of inputs, not just a few, from different kinds of facilities, the average percent reactive maintenance in North America is, for top quartile, top 25% is 9%. So they get it. They're at that 10%. And I poke at reactive maintenance because to me it's one of the first things you need to get better at and improve so many things. If you're highly reactive, you never have enough spare parts. There's a lot of things you can do, tied into your MRO crib. And just having that high level of reactive maintenance, if you do that, backlog will increase since you're using limited resources that should be doing other things. If you're fixing stuff too often, you're just reintroducing some form of infant mortality in a lot of places in your equipment. Increased reactive maintenance impacts your safety. Running to failure, and praising firefighters is never going to get you there. So I can go on with 50 items. Most of us know that emergency repairs cost, I've seen, from 3 to 10 times more than planned maintenance. When I look at my benchmarking data, if you're in bottom quartile in reactive maintenance versus top quartile, just in maintenance costs, it costs you 6 times more to run the business of maintenance. That's not what you lose in production costs. So, we can go on and on, but you just got to get better at reactive maintenance. So I'll move on to the next slide. So again, from my data, over half of the facilities and factories in North America still rely too much on reactive maintenance as a major part of their daily maintenance activity. If you look at, kind of what's going on, it's easy to ignore kind of those little things because they never seem that important. It's kind of like, hear no evil, see no evil, speak no evil. I see it, but I don't really speak up, or I don't try to fix it because it's been going on for so long. But the issue is individually, 1 or 2 little things may not be that big of a deal, but it's usually not 1 or 2 little things that are done incorrectly in a plant. It's dozens of things every day. And cumulatively, that just destroys your process. And you can never get better if you don't fix those informal things that are happening or those things that are ignored. And by those kind of things, just a few examples, I mean like taking verbal job requests that should be formal work orders, where you get to the job site and operations doesn't let you take the equipment because they want to run just a little bit longer. Or you get unclear maintenance tasking direction, so they improvise, they do something. Or do people prioritize a lot of their work as safety just so they can get higher on the list because your backlog's so high? And or they struggle to find the correct part because all the parts are not coded with standardized systems, a problem that also impacts reordering, etc. Or learn that some of the asset history is only being captured because a lot of the work orders aren't being closed out. And obviously most people have, skilled trades hoarding parts because they don't trust the stock rooms. And we can go on and on, or you don't do the root cause analysis because you don't have time because you're doing so much reactive maintenance. So, individually, it's not that big of a deal. But when you cumulatively putting all those things together, those many little things going wrong, ignoring so many things that individually don't seem that big, make your R&M process dysfunctional. How do you get better unless you fix that first? And what I see, in a lot of places is people not being held accountable for following the plant processes. When I go into a plant, I usually ask 3 questions. Do you have a standardized work process? You have individual small team continuous improvement, because if you're not finding and fixing, how do you get better? You're just doing what I call maintenance insanity. Like Einstein said, if you do the same thing over and over again and expect better results, that's insanity. Well, if we don't do the finding and fixing and then checking that it actually worked, if you look at it at a big enough window of time, you're just doing maintenance insanity. You're fixing the same stuff over and over again. You have a methodology to improve and sustain the thinking process to one of ongoing improvement. Meaning, are you really doing coaching so you're developing a plan of problem solvers? Kaizen events are good, but Kaizen events are not just coaching. So with that, let me jump into the third polling question, Eric.
So the question is, how much of a roadblock is cultural change? Is it a minimal issue for you? Is it a moderate issue? Is it a significant issue? Or is it the largest issue? And it looks like most people are saying it's a significant issue, and a lot of people are also saying it's a moderate issue for them.
Yeah. So those that are doing better with culture, so congratulations. That's good. What I see is from hundreds of companies, over 70% of the companies still point to culture as the main roadblock to reliability and maintainability improvement. But the same could be said for implementing lean manufacturing, total productive maintenance, individual things like root cause analysis, and we can go on and on. And the difficulty in changing from a reactive to proactive mindset, it's just tough. If you've done something, let's say not the best way, I won't even say the incorrect way, but not the best way for many, many years, for you, that's the best way of doing it. And that's the plant floor is going to fight that. So we've always done it this way. And how do you change that? And so you've got that historical dysfunctional process ingrained in the culture that just doesn't want people to go forward with a change. I also see that many organizations think they're better than they are, until they really understand the benchmarks and what could be done, and what the real, once you monetize what the real opportunities are, they realize there's still a long ways to go. And I think, people also need a better understanding of how it's all related and how it really impacts everything in operational excellence. I think that's not fully understood. So there's not a lack of support from sometimes other functions, and a lot of places are still silo oriented within their organization. And so a big part of it again is the culture, and I'll put up a couple slides on that. This was some stuff from the Jim Collins Good to Great book. We had some opportunity to do stuff with that when I was doing benchmarking in Europe and looking at some of that stuff with the teams, with these teams. And one of the quotes he put in his book, it says that all companies have a culture. Some companies have discipline, but few companies have the culture of discipline. And that's what you really need. That's what we're talking about: standard work, people being accountable, people being held accountable. How much easier is your job at your place, whether it's office or work, if everybody does what they're supposed to do? You don't have to worry about how good did they do it. And when you have disciplined people, you don't need hierarchy or as much of it. When you have disciplined thought, you don't need bureaucracy. And when you have disciplined action, you don't need excessive controls. And with that culture of discipline, where people know what to do, are capable of it, willing to do it, that's when you really get that great performance. And when I did, like I said, I do ongoing benchmarking, but a little over 10 years ago, the big result from one of the surveys was that, again, if we don't get better at culture, especially at the plant floor level, continuous improvement maintenance is going to come to a screeching halt. We're going to get a point of diminishing returns. And I'm seeing that with data now. You know, since it was like back in, gosh, 1991, when I was doing some of the benchmarking for GM, reactive maintenance for North America was about 54%. That was the average for North America. Then it worked its way down to about 35%, 34%. And then around 2012, and so it got down to, 2017, 2015, it got to about 31%, and it's pretty much stayed there. I looked at it again about a year and a half ago, and it was still 31%. So I'm in the process of doing a much larger study to reconfirm that. But exactly what they told me 10 years ago, I'm seeing with data. If we don't get better at problem solving and engaging the people on the people side of the business, individual plants are getting better because they get it. But on average, North America has stalled. They're at 31% reactive maintenance for the last 5 years. And when I look at, what do the best plants do, and what can and should you do? Most of the stuff's pretty straightforward. There isn't anything magical, but first of all, you need to acknowledge the need for change. Because again, most places think they're better than they are. You got to recognize it's a journey. I see a lot of journeys starting, and you get some good results, and then management wants to push real fast to accelerate it. They destroy the journey. It's a journey. You get there not by cutting maintenance costs. You get there by implementing the right processes in reliability and maintainability and developing that maturity. Maintenance costs will right size as you improve those processes. But while you're improving those processes, the big savings will come from decreased downtime, more throughput, more product out the back door. That's where you're going to get your big savings by a factor of 5, 10, 20 of anything you're ever going to see in maintenance. You can reduce some costs in maintenance. You can free up resources by a good PM optimization program. You do a good parts rationalization. You can do a lot with your stores. I've never been in a place that we can't remove from 10 to 30% of the stores because they're obsolete, don't need to be there, etc. So again, there is money to be attained from maintenance also, but the big savings are going to come from operational improvements by doing the right maintenance and reliability processes. You obviously need to do a gap analysis, do some kind of assessment. It doesn't need to be a huge assessment, but you need to know where you're at and what's possible. And you need to get good at monetizing those opportunities, and so you understand how big they are. And I think most people are doing some of that. And you need to understand how it's all related, because as you go forward and do certain things better, all of a sudden a lot of things become a lot easier. And all of a sudden a lot of the KPIs start to accelerate, or they get better at a faster rate, because a lot of the things are starting to work better together, like putting a puzzle together, right? It's slow at the beginning, but as more things get in place, it starts to get easier and faster and better. This kind of implementation is no different. Again, you need leading lagging KPIs, but more importantly, or as importantly, is you need to reward the behaviors that support those KPIs that you're looking for and develop problem solvers. You got to learn how to coach and reward behaviors to develop those problem solvers. And as I went to hundreds and hundreds of plants to look at the best of the best, like through the Jim Collins book and so on, the main difference that I saw were very subtle, from the good plants to the great plants, or the best of the best. And again, there's no corporation that does everything well. I've not found it yet. Individual plants do a pretty good job. And I haven't found a plant that's top quartile in every metric. I'm not sure it exists, because there's always compromises in the real world on limited resources. But the three things that I see that people need to do: number one, small team and continuous improvement. You got to get good at it. You got to get good at finding and fixing. If you're not spending 20, 25% of your resources doing the finding, and that's not the work orders fixing, another 25, 30% fixing, that's half your resources, finding, fixing. That's what top quartile North America is doing to get 9% reactive maintenance. They have a North America average for finding stuff with technologies, routes, and so on, is 23% of their resources by hours is finding. another 30% doing the work orders fixing. So they're doing that finding and fixing, they get it. The other thing the best of the best had in common, they have a common practical problem solving form or process that they've rolled out. So everybody from the person that sweeps the floor to the plant manager speaks the same language, and they're all focused on doing the same continuous improvement practical problem solving process. You can use an A3 type form, practical problem solving form, but it doesn't have to be that. You just need what you're really doing is trying to get everybody on the same mindset and thinking the same way about continuous improvement and problem solving. And the third thing you have to do is the check and the plan, do, check, act. And that means go out to the plant floor every day and not say you're not following standardized work. I kind of tie this into a lean sensei, Gemma walk, kind of the plant floor walk's probably the best way. You never give the answer. A lean sensei never gives the answer. You learn how to ask the questions so your plant floor knows how to get to the answer. Because it might take you 3-4 times longer because you might have to go out there a few more times to get to the same conclusion. But you want to walk away having more problem solvers on a plant floor, not just they're doing it now because I told them. That's the difference between standardized work and coaching. So you need to learn how to do that. So those plants that were the best of the best, and it sounds so simple to do, but I call it so difficult to implement, or there'd be a lot more people doing it. So when you look at all that, and there's surveys out there that happen in some every year, some every other year, whether it's plant services and different magazines that still say 50 or 60% of the people are not happy with their predictive technology program. Well, why is that? The technologies are getting better and better. Technologies are great. It's the implementation, the engagement, the people side of the business that's failing. So whether you look at the reliability, maintainability, TPM, implementing technologies, and it's going to be the same thing when you're looking at machine learning and putting all these other digital programs in place. It's also a socio-technical process. That just means you got to work on the organizational health, the engagement. It's half a people issue. It's half a technology and asset issue. And we don't need to talk through all the individual items, but whether it's reliability, maintainability, lean, whether it's PM optimization, whether it's 5S, whether it's TPM, you got to have that culture of discipline, and you got to have that engaged workforce to make a difference, or it's just going to be tough to get there. You need good processes in place. It's not just about culture. You need good processes in place, but a good culture will help you get there faster. If you're fortunate enough to get there, it will help you sustain. This slide here on the left-hand side, you have organizational culture. On the bottom, you have plant reliability and maturity. So if we roll out reliability and maintainability in 14 different modules over 3 different layers, and we just call that as you implement all those pieces properly, we say that's the maturity of your reliability process, and we assess that for some plants. And these are 8 plants that do pretty much the same thing, that actually went through not a 3-day, but actually an intense assessment with hundreds of questions and interviews and et cetera. So it was more than just a survey. And as you can see, culture was pulled out separately as part of the assessment. The other 13 elements, the average of those were plotted. As you can see, there's a pretty good correlation on maturity of the reliability process with culture. Now, how much has culture influenced the process? How much does working as a team in the process improve culture? I don't know, and I really don't care, as long as they support each other. And now, I have other people, or plants that I work with that are on a different improvement trend. They're on that red line. They start a little bit lower. Their journey is going to take a little bit longer, but they'll get there too. And you can do this with groups of plants like this, or you can do it with a single plant over time to see if you're getting better or not between culture and processes and so on. And the advantage of culture is you may start with that X's on the bottom left, but if you have a much better culture, you'll cross that top line that has the green shading around it. You'll cross that top line a lot earlier if you have a good culture, and you'll be more likely to sustain it. Because I also see people get there, or plants get there, and they can hold it there for 3-4 years, and stuff happens and they start to fall apart. So it's tough to even stay there once you get there. But again, you need culture, not just the performance focus. This is the model that we use. We kind of work on creating the culture. As you can see, it's not just culture. It's also the goals and metrics, your roadmap, what's your reliability network between sharing improvements, what's your reliability network within the plant. Does the entire plant understand why that's important and what you're implementing? How is your data integrity? Are you, how good is your data? Are you willing to make the tough decisions based on data you're collecting from the plant? I'd say 90% of the people aren't, from what I'm seeing right now. And as we get into some of the future stuff with all the digital stuff, you don't clean that up. How is that all the digital stuff going to help you? And then you get into standardized work and all the processes from work management, planning and scheduling, the computerized maintenance management process. That's when you're getting into preventive maintenance, your condition-based maintenance, your predictive technologies, your materials management, lubrication, and then an optimize and sustain. Hopefully at some point, purchasing will be involved with life cycle attainment of assets and have some responsibility over that, and be able to spend it's not just purchasing, management has to allow them to do it, to be able to spend a little bit more money to design it right, to save the big money over time. And root cause analysis is a placeholder for us for all the root cause analysis tools, because we actually teach 12 different root cause analysis tools, and that would include like FMEAs, lots of different things. And equipment and process design gets into your design for maintainability and how you're designing equipment, buying it off, and so on. And that really is there. All those things are there to support not just reliability and maintenance, but it's overall lean programs, total productive maintenance, and then how do you do the plan, do, check, act, and coach and mentor the floor to sustain that, to be able to continually do continuous improvement. When I look at what's coming up, this is a similar version of what I started with from the John Mowbray book, but kind of where does it go from here, and what's happening? As you can see, it took 30 years to get to that first zone of uncertainty to the next zone of uncertainty. By that I mean people weren't sure how fast to move forward to some of the new stuff. What do I do? How fast do I change? Should I be using machine learning now, or is it too early? Do I have data that I can trust to do machine learning? But as we get closer to today, I'd say about the stuff that was there in 2010 is about what we're doing, in most of the stuff now and implementing, from precision, more precision maintenance, more big data, real time. People are doing more systems thinking, getting more into wireless mobility. Analytics is getting more comprehensive. They're getting more into prescriptive maintenance. That's where machine learning is now doing algorithms and looking at data. And as you're doing more machine learning is now generating work orders based on what you're doing. So you may look at something every month, but after enough data, your machine learning might say, based on what we know now, you only need to look at it every 4 months rather than every month. And so the machine learning is doing the prescriptive maintenance. Edge computing we talked about. Augmented reality, I'd say, digital twins. Some people are paying big bucks to move forward with this, but I'd say it's still in its infancy, and a lot still TBD. I think it's good, a lot of good applications, but still needs to smooth things out as far as implementation and day-to-day use for the majority of the facilities. But I think it's coming, but you got to clean up your data. Machine learning, a part of that, artificial intelligence will be on top of that or with that. Then there needs to be a new look at your total asset management system and how do we transform and integrate to this new, more IT involvement, or maintenance people that are doing more IT type stuff with data analytics now, and how does that change how you maintain and what you maintain and who makes what decisions. And supply chain has already changed and shown a lot of weaknesses over the last year and a half because of the COVID issues. But supply chain will change also as we do manufacturing differently and as we do more additive manufacturing. And as I keep putting up there, that's a wish and a hope that purchasing gets more tied into life cycle costing and R&M. But all of this is going to mean we need new business models. And so I expect and hope to see more things around new business models for reliability and maintenance, and we'll be looking at that also. And then down the road, at some point there'll be neural network AI, which is more like how the brain thinks. That's still a ways off on that. other than various research and specific applications. And once they get a hold of quantum computing, that won't just be a game changer, it'll be a world changer. Now you can go 1,000 million times faster, 1,000 or a million times faster in some things, but to make the physics for quantum computing work, you need to have temperatures close to absolute zero, like outer space. And so there's a lot of, and some are getting success at lower temperatures, but there's a lot of physics around that. But once they figure all that stuff out, that will be a world changer as far as data. But even many years ago, people are publishing that there's more data been published in the last 2 years than the history of mankind, and that's accelerating. And so here we are, still need for better culture, need for better data, because people still are making tough decisions based on data. They're kind of using it to look in the right direction, but not make the tough decisions. So I see us right now in 2020, from 2020 to maybe the next 3-4 years at least, still in kind of a zone of uncertainty. How fast do I jump on board? Now, how fast can I make these changes? What should I do next? And so on. Because when the studies that I see, it takes 15 tries to get the technologies to work, applications. Well, most people don't have the money or stomach to try 15 times. Some people are throwing the money at it that have it, and they'll get it to work. But at some point, it's going to be plug and play. It'll work a lot better, a lot easier, a lot faster, but you got to have data that you can trust so you can work on that now. And what you also look at, when you look at the time spans of all these dramatic changes, 30 years way at the beginning, another 30 years for the next step, 10 years for all the new stuff from precision maintenance to machine learning and artificial intelligence. Now 5 years, we're going to see even more drastic changes in the next 5 years. So this change is even accelerating more. So that's why I say, we need better, different business models to be able to drive what's coming up. There's a survey I was involved with that was actually global. I helped put together data, and companies that we work with at the university and other companies contributed information. And this was the results, and it kind of shows that the digital technology adoption, still at its infancy. So it's just a scale from no adoption at 0 to 4 being full adoption. And as you can see, 3D printing is down there, not even at a 1. As most of these are only around run. The highest one is remote control, monitoring. And machine learning, stuff there is not a 1. So most of these still in the infancy in North America based on data that I've looked at. So we'll publish some more of that as we go forward. So what does all that mean, and where do we go? We know it's going to be disruptive. You got to decide, or you're going to play, you're going to get involved, you're going to wait and see what happens. It's going to change with or without us. So I always say, take action, make things happen. Change your perspective. Don't wait for things to go back to kind of how they were. Some things will go back to how they were. Many things will not. If we wait for the change, it's too late. Everything's changing at an accelerating pace. But I got to say, remember the practical. We're getting so much data, but the practical tools to allow us to be able to use that data really haven't kept pace, at least at a practical level, affordable level. And so remember the practical, and so we try to look at those kind of things. Figure out how to connect the retirees and the millennials before it's too late. You lose a lot of that knowledge. Align the goals, get them working together, and I see some of that happening, but not enough. Interconnectivity, still a big issue. Can everything talk to everything? Get on board. But number one is get your data ready so you can trust it, especially data where there's human input. And the change is happening whether we want to or not, or whether we like it or not. So protect your base, stimulate innovation, and decide how you want to play and what's happening in the future. And good luck with it. But I think it can be good and it will be good. But you got to take a proactive role on everything that's going on. So with that, I think that's pretty much the end of the presentation. I thank you for the time. I'll open up for any questions and turn it back to you, Eric.
Thanks so much, Klaus. That was great. We do have several questions that have come in. And as a reminder, if you still have questions you haven't added yet, you can plug them into the Q&A chat box there, and we'll answer them as time allows. The first question someone asked is, can we have a copy of the materials presented? And the answer is yes. We are recording today's webinar, and we'll send it out to all of you. We'll also be available online at excelix.com.
Yeah,
The next question, Klaus.
We'll make available a PDF file of the slides, and obviously the recording will be available.
Yeah. The next question for you, Klaus, is in your benchmarking studies, what percentage of companies are using their CMMS data for maintenance optimization? Are these companies with low reactive maintenance?
There's obviously the ones that are doing a little more digitally, making decisions based on data, do better, but it's still a lot less than I'm happy with. Probably maybe 20% are, but only 25% are obviously only in the top quartile, or it wouldn't be a quartile, right? I did a different study that might help answer that question a little while ago. I looked at a lot of the different software packages, whether it's Maximo, N4, whether so on. It just doesn't matter. I looked at used about 7 or 8 different ones, and I what they were actually using and applying. What out of the capabilities of their CMMS system are they really using on a day-to-day basis? It came out that on average, North America is not using 30% of the capability of any CMMS system, which is kind of sad. And when I say that in plants, when I talk and do assessments, they say you're even high. We think it's closer to 20% from what they see. So it says, some people obviously are doing more, but maybe they didn't, they don't have access to the change master, didn't pay for it. Now changes are expensive. Maybe they're not doing the bill of materials. It just goes on and on. Or that software they bought doesn't integrate to everything that they want. Use something else, or they do something on an Excel spreadsheet, even though they have the software. I still see way too much of that. And so you've got all these great software systems, but they're bought, but they're not fully integrated. And Smith's the best answer to the question.
Awesome. The next one is, what can we do to get from reactive to proactive, and how do we go about that cultural change?
Well, first thing is get started, I mean, I kind of say, there's 4 things you got to do, and McKinsey's published some stuff. I've written some things. I kind of try to simplify it. Say you got to be willing to change. You got to want to change. You got to know what to change, and then you got to work the change. Then you got to keep asking, why am I changing, and do continuous improvement. It's kind of a simplified version. But if you get into the details on some of the studies that have been done, there's four levers that provide the influence model that McKinsey has published. One is you need a compelling story, like you need understanding and conviction. And so if a person is saying, do I want to change? Do I want to do this proactive? They're gonna typically look at 4 things. One is, do I understand what's being asked of me and does it make sense? That's that understanding and conviction. And then they're gonna look around and say, what else is happening? Are there support mechanisms? Are there reinforcement mechanisms? And from an individual standpoint is, do I see our structures, processes, and systems supporting the changes that I'm being asked to make? So is this going to be real? And then the third thing is, do I have the skills and opportunities to behave in the new way? Meaning that if you're saying, well, you got to do precision maintenance, but you never sent me to precision maintenance training, do I really have the skills required for the change? So you got to work on that confidence and skill building so that the employees do have the skills and opportunities to behave in a new way. And then the third one is what you'd expect, is the role modeling. Do I see my leaders, colleagues, and staffs behave it differently? Are they coaching and rewarding the new behavior, or are they patting everybody on the back that's doing reactive maintenance and saying, great job, you got us up running again? Doesn't mean they did a bad job, but the question ought to be is, what are you doing to make sure that never happens again? Are you doing the root cause? Because the role of maintenance and reliability isn't to do it faster, better, more often. It's to, what do I have to do so I never have to do it again? That's the real role of maintenance with reliability. What do I have to do? How can I design it out so that it never happens again and I don't have that repeat failure? So that's it.
So the next question builds up that one a little bit, Klaus. Are companies that are implementing CMMS solutions codifying best practices into their systems, or are they just codifying whatever practices, best or poor, into their systems?
I think most people are still learning. I mean, everybody hopefully is following some kind of model. It doesn't have to be ours, but the key thing is, they've got to follow a roadmap. And from what I've seen is those that do more in a structured process and follow a disciplined process and are digitizing more of it using their CMMS systems, over time they're having better successes. But I think most of them, it's still a learning process. It's still some trial and error.
Okay. The next question says, so can we conclude that human interaction and work culture are still important even for the distant future, especially in the digital era?
Absolutely. Maybe even more important. Because all the data is not going to be digital, but that human data has to interact with the digital data, and they both got to be good.
All right. The next question is.
Let me give an example. Sorry.
Sure. No, go ahead.
Give an example. I've worked with companies that, are saying, how can we leapfrog the competition? What can we do? And I spend time with, global plant managers, offsite on their annual meetings, looking at all this stuff and seeing how they can go forward. And when I look at what they have people that know reliability growth. They have experts in Weibull analysis that, heck, I wish I had. That just phenomenal people. And I says, why aren't you doing this? I mean, you got the talent. So we don't trust our data. We don't trust our data to make the tough decisions. So that's why I always say, you got to get to where you trust your data. And just going digital, you can't collect everything digitally to make decisions on your operations. It's going to get better, but you can't collect everything. And again, that human data has to interact with the digital data. And then do you trust it to make those tough decisions?
Great. And the next question is, are there a list of processes that should be standardized at the beginning? I saw you said work process standardization. Are there any other fundamental processes that companies should have in place?
Well, it really depends on what you're trying to do. I mean, if RCM has certain things you can put in place, if you're doing lean manufacturing, if you're doing under lean manufacturing, we implemented lean manufacturing when I was in corporate world, 30 some modules. But what I would say is in all of those, you got to do some kind of pilot. Just like in lean, one of the first 5 modules is always 5S. And some people fight 5S, and the trades might say, "Oh, that's childish. Why do I need to do it?" And they say, "Oh, Joe, he's our best trades. He does everything we ask, but he thinks it's childish." But you see, all of a sudden, you see all these holes in 5S. But 5S isn't just about doing some continuous improvement and workshops and cleaning up some of the workplace and getting some standardized work there. What 5S really is, it's a test of your culture and discipline. If you can't develop the culture and discipline to do 5S, you will fail in lean manufacturing. And I say what I see is 70% of lean manufacturing fails around the world. And when I say it fails, it doesn't mean that you don't get some benefits, but you get less of the half of the benefits that are attainable because you don't have the discipline and the culture to follow things even in 5S. And I see that in plants, and I ask them, how are you doing on lean? Oh, we're rolling it all out. It should go pretty good. Well, how can it go good if you don't even have the discipline to do 5S, which isn't easy, but it's one of the easier modules. If you can't get the culture and discipline going there, how do you do the rest of it and trust the system and the data? So that's it.
Here's a good one for you, Klaus. In my organization, the cultural change is driven by entry-level and production employees, but often held back by middle management. What approach would you recommend to be able to instill change in those with the fiscal and structural authority to allow change?
Well, it would be nice if if the people on the floor could get someone to come talk and get beat up and so on, because sometimes it is management. It doesn't want to change. I won't mention names of companies, but one company I'm working with, they just had a big change in management, and it's a much younger management group now in the 40s, and they understand the cultural engagement part, so they're rolling out all the processes, learning how to coach the floor, and they're seeing the successes, doing the 5S, workplace organization, and so on. I've been other places, whether it's Europe and over here, where a vice president actually took over a plant because they were going to go under if they don't operate better. And this place had over 200 facilities, so they weren't going under. Just this one plant making those particular products was having a problem. And I got there about near the end of their implementation of what this vice president took the active role of plant manager, was to change his facility. And he shared with me his 30 PowerPoint presentation that he gave to those. First he gave it to the people on the floor, and they were in shock at how bad they were doing compared to the competition and what they could be doing. And they said, no one ever told us that. They said we were doing a great job, et cetera. It was all buddy, and culture was good. And then he gave that same presentation to the management, and the management told them, "Sir, you don't really get it. We think we're doing a pretty good job." Well, obviously it was the management that was a problem. This is not going to help the answer directly, but a third of the people at that plant took early retirement, a third went elsewhere, and a third actually changed and stayed there and worked. And now that plant is producing in one shift what they used to produce in two, and that took 2 years. So, so the issue that for the question is, how do you get it to the management? Whether it's a guest speaker, whether somebody is close enough to management, even at the middle management or at the floor, that they can talk. Because I give another example. I've been to places where I've been asked to say, can you kind of give us an overview of where we need to go and what we're doing? I wasn't involved in the implementation. And as I'm about halfway through my presentation, the vice president says, well, you've got really good data. It's kind of what we do. And I told him, I said, sir, this is your data. This is my third time here. First time, you had a bunch of stuff going on and you cut a bunch of resources and somebody saved a lot of money and looked good, went on to someplace else, and you destroyed your process. Second group got me in, and they did a good job, rebuilt their process. Then some mergers didn't work, and you gave those guys early retirement. You're the third person asking me in, what should we do? So the question is, what are you going to do different? Management needs to understand too. I've seen other great success stories. We've had keynote speakers at our conference where people just below vice president or vice presidents that later became senior vice presidents are giving the reliability and maintainability talk, most of which they made input to themselves, and they give the talk off script. They understand it, they can talk it, they field the questions. That's a different level of involvement of what it can do for a corporation because they understand and they got there. So, well, long answer to a short question. So.
Awesome, that was a great answer. Well, that's all the time that we have for today, actually. So I do want to say thank you again to you, Klaus. I appreciate you taking the time to share your insight and expertise. If anyone else has additional questions or want to connect directly with Klaus, his contact information is here on the screen. I'll also just add, this is our last best practice webinar of 2021. So thanks to everyone who joined us this year. We're currently finalizing our lineup of best practice webinars for 2022. And we'll be posting those to our regular place, www.excelix.com. And we'll also be sending out some promotions about them as they come up. So thank you everyone for your time and have a wonderful rest of your day.
Hey, thanks everybody.
All right. Bye-bye, Klaus.
Bye-bye.